should be flashing at the top of your screen in a second or two that I'm recording now. Okay, now, unfortunately, my pen that I use on the computer has just stopped working, so I think the battery's gone. So that might affect the thing I was going to do at the end of the lesson, the proper bit of the lesson. But not to worry, it's a revision lesson, and you will just have to look back at your notes for this. So what I'm planning on doing, we're going to have a proper recorded lesson for about 10 minutes, 15 minutes. And then just for a bit of fun, because it's the last day of term, we'll just do a Kahoot. All right, so I'll stop the recording for that. And at that point, not before, but at that point, you can unmute your mic, okay? And then you can all join in a bit then, all right? Because that's not a proper lesson, that's just mucking around a bit. But for now, I want this to be a formal lesson so that we can properly, you can make notes, but importantly, I want this recorded. So for the 6 of you who aren't out there, you can just watch the recording in a bit. So hopefully you can all see my screen now. So what we're on to now is revision 6, which is revising set theory. Okay, and we didn't do this that long ago. We only did this on the 10th of March. So this is only about 3 weeks ago. Okay, so you can make the odd note if you want. If you're quite slow at note taking, that's not a problem. You can obviously just play the video back when it's the recording back, which comes up a few minutes after the lesson's finished. And you can obviously stop the recording whatever you want, and that will give you the opportunity to make all the notes you need. So I will go quite quickly now because I want to keep these videos quite short, because otherwise, if you're wading through a video and there's great pauses in it, it does make it very boring. So here we go, set theory. So a set is a collection of terms often written inside curly brackets. So we know that, so that would be an example, okay? And then the other thing you started getting used to the idea of is this squiggly thing down here. This is called the universal set. So for a question, those are all the numbers that you need to consider. Just think of those numbers as being your universe. That's the only numbers you need to think of. And say you were doing a Venn diagram, then you just need to make sure that all those numbers in that universal set, you plonk somewhere. So maybe they're inside the rugby balls, maybe they're outside the rugby balls, but inside the rectangle. But the universal set is all the numbers you need to think about. So I want us to just go and have a quick think about this example 1. Again, you've seen it before, it's the same slides. So you can just think of these in your head if you like, and then write them out later, or if you're a really quick writer, you could write these down now. So for this example 1, if this is our universal set, if these are the 10 numbers in our world, and then we're being told that set A is all the even numbers, which are the numbers that are going to be set A, and which of the numbers are going to be in set B. Set B is the numbers less than 4. Excuse me. So the even numbers are going to be obviously all the even numbers up in our universal set. So that's just going to be 2, 4, 6, 8, and 10. And obviously the numbers less than 4. So set B is going to be the 1, 2, and 3. So we don't include the 4 because it says numbers less than 4. So that's the 1, 2, and 3. So that's easier enough. Now, I also introduced you to what's called the complement of a set. And the complement of a set is all the numbers which are not in the set. And the way we write down a complement was just to do this little dash here. So A with that little dash means the complement of A. So that basically means all the numbers in our universe that are not in A, okay? All the numbers up here that are not these numbers here. So obviously that's just going to be all the odd numbers, isn't it? So that's going to be 1, 3, 5, 7, and 9. Now the complement of B, so which numbers in our universe are not in B? Well, it's obviously going to be the ones that are not 1, 2, and 3. So it's not 1, 2, and 3, but there are these numbers up here. So it's all our universe up here, but not 1, 2, and 3. So that's got to be the 4, 5, 6, 7, 8, 9, and 10. So that would be the complement of B. Okay, so that was all quite straightforward. So whoops, gone too far ahead there. So what I want you to do here, please, to start off, No, yes, this is a new example. So example 2. So can you please just, I want you to do this one, please. Can you, so copy this one out. So new question. That's our universe. 1, 2, 3, 4, 5, and 6. I'm telling you, the question tells you that A is the even numbers and B are the numbers greater than 3. And for now, I just want you to do the bits in red, please, not purple, just in red. So for this example here, this example 2, can you just go and work out these 4 things here, please? While you're doing that, I'm just going to have a quick fiddle with the pen and see if I can get that working. I've got a horrible feeling the battery's run out, but I'll see if I can get it working. No, I can't get that pen working, that's a shame. Never mind, I'll get a new battery from Amazon. So, in A, what are the even numbers in our universal set? So clearly that's 2, 4, and 6. Which are the numbers? So B is the numbers greater than 3. So what's greater than 3? That's obviously 4, 5, and 6. Now, not A. So what numbers in our universal set are not 2, 4, and 6? So that must be 1, 3, and 5. And then which numbers in our universal set are not in B? So they're not 4, 5, and 6. They're not in B. They're not 4, 5, and 6. That must be 1, 2, and 3. So pretty straightforward, I think. Now, the other bit, and I would say this is probably the key bit that you've got to learn, okay, is the difference between intersection and union, okay? The difference between intersection and union. Now, intersection, which is this sign here, is when a number is in both A and in B. So A intersection B means that you've got to be in both A but also in B. So you're both in A but also in B. Okay, so you've got to be in A and in B. So which numbers are in both? And you can see that's the 4 and the 6. The 4 and the 6 are both in A and in B. Now, union is different. That means that you're either in A, or you're in B, or you could be in both. So it's a much bigger set. Okay, so it's all the ones that are in A, so that's 2, 4, and 6, but also those that are in B as well. Well, we've already got the 4 and the 6, so that's also going to bring into play the 5. So A union B is 2, 4, 5, and 6. Okay, so what I would like you to do, well, this is going to be, this is the one where I was hoping to use my pen, okay? So this is going to be fun because I haven't got, I'm going to have to do this with the mouse, which is going to make my writing look absolutely ridiculously bad. But there we go, we work with what we've got. So please can you start off by working out what the numbers of A are, please? Can you start off by doing what are the numbers of A? So copy out this question, please. We're going to move on to Venn diagrams in a minute, but what I want you to do first of all is to write down all the members of A, so that's not too bad, all the members of B, and then all the members which are not A, and all the members which are not B. So can you just please go and do those now, while I try and do it using my mouse, which is really hard. Okay, so you're doing 4 things for me at the moment. With this new question here, you're writing out the members of A, so all the even numbers that are in that universal set, all the members that are in B, and how do you get in B? You've got to be greater than 6, then not A and not B. Right, just trying something out, guys. I'm just warming up the battery of my pen on the Arga. Just going to see if that's going to get it working. Right, okay, so what were the even numbers here? The even numbers are obviously 2, 4, 6, 8. Sorry, you have to excuse my writing because I'm doing it with the mouse. 8 and 10. And the members of B are the numbers greater than 6, so that's obviously 7, 8 and 9 and 10. 7, 8, 9 and 10. Right, the members which are not A, so not 2, 4, 6, 8 and 10, so that's 1, 3, 5, 7 and 9. And then not B, so not 7, 8, 9, 10, that's 1, do you know what, I'm just going to write them all down. That's 1 all the way up to 6, okay? 1, 2, 3, 4, 5 and 6. Now, what I want you to practice now, which is probably the key bit of the lesson, can you go and tell me what members of the universal set are in A intersection B? And also a union B, please. Okay, so A intersection B, just to remind you, A intersection B was you're in A and you're also in B, and then A union B was you're in A or B or both. Okay, so A intersection B, it means you're in both A and in B. So A is 2, 4, 6, 8 and 10. B is 7, 8, 9 and 10. So what numbers are in both? That's the 8 and the 10. That's the 8 and the 10. Right, the 8 and the 10. And we're going to put that in. Oh gosh, this isn't working now. The 8. Whoa, 8 and the 10. Oh dear. So that's 8 and 10. That's supposed to be a 10. Oh dear, it's just not working for me today, is it, the technology? That's the 8 and the 10. And put that in the squiggly brackets. And then A union B that's got to be what's in A or B or both. So it's got to be in A, so that's 2, 4, 6, 8 and 10, but also in B. So that's going to add in the 7 and the 9. So A union B is going to be, oh dear, I'm just going to have to say this, guys. A union B is going to be A or B or both. So that's the 2, the 4, the 6, the 7, the 8, the 9 and the 10. Okay, 2, 4, 6, 7, 8, 9, 10. Okay, so the next bit I wanted to do was Venn diagrams, but I think unless I can get the pen working, we might have to leave that for another day. Okay, so I'm just hang on there. I'm just going to go and grab my battery. Right, moment of truth. Is the battery going to? Is this pen going to work now? Yes, it is. Wow, that's what warmed it up. That's worked. Right, so let's just quickly finish off what this should have been. So A union B should have been the 2, the 4, the 6, the 7, the 8, the 9, and the 10. Super. Right. So now the pen's working, we're back on track. So same question. Okay, so now we're going to look at the Venn diagrams. So what I want you to do, please, is just to quickly, can you just go and get a number of Venn diagrams ready? Okay, so just like I'm doing here, can you just go and get, let's say 3 Venn diagrams ready? All right. So I want you doing the same. Okay, so in the first Venn diagram, I want us to go and shade the area, what you think is A intersection B. And then in the second one, I want you to go and shade what you think is A union B. And then in the third one, I want you to go and shade the region that you think is not A. Okay? So just go and do those 3, please. So A intersection B, A union B, and not A. All right, so just go and shade the areas that you think satisfy that instruction. So remember, A intersection B, which area is in both A and in B? A union B, which area is A or B or both? And then thirdly, which is the area in our universe which is not A? Okay, right, so A intersection B is clearly the bit where they overlap. Okay, so that's just you're in A and you're in B. A union B means you're either in A or you're in B or you're in both. And then not A, now think what A would be. A would be anything in A. Somebody's just switched their mic on by accident. Okay, so that would be A. We want everything that is not A. So, okay, that's going to include that bit of B, but it also includes the rest of our universe. So for this one, you've just got to shade everything which is not A. So just imagine that you've lightly shaded A. This is absolutely everything else in our universe. So easy to forget the bit outside the rugby boards. All right, so that would be... All right, so that would be not A. Now, 1 to finish. All right, one to finish. This is a really tough one. So go and get another Venn diagram ready. This is a real challenge. Okay, I want us to go and shade the area which is A intersection not B. Okay, so what we're saying, what area is doing two things? It's got to be in A, but at the same time, it mustn't be part of B. Okay, so what area is in A? So picture where A is. So that's what you're thinking to start with. But at the same time, it mustn't be in B. I'll give you a few seconds to ponder that. So what's A intersection not B? Okay, so have a think. So we've got to be in A, which is obviously the whole of the A rugby ball, but at the same time we mustn't be in B. Now that's all of B, isn't it? We mustn't be in B, so we mustn't be in any of that area there. So that also includes we mustn't be in that bit there. Okay, we mustn't be in that bit there. So the area that we want is this bit here. All right, that is not, that section there. Is it in A? Yes, tick. Is it not in B? Yes, tick. So that is the answer to that. So, sorry about that bit in the middle of the lesson when I couldn't have the pen working. That's a good tip. I don't know if any of you know that, but if the battery's not working, you want to extend its life a little bit, just warm it up a bit. Not so much that it explodes, but just pop it on the radiator for 5 minutes. Right, okay, so I don't want you guys going yet. I want you staying silent until I've stopped doing the recording. Okay, and that takes me a while because Teams is quite slow here. So I think I've stopped the recording.